There's one last type of graph that we use, and it's called a two-way table. And it displays two categories, obviously two-way, that are collected from the same source. So, for example, in this two-way table, we took a survey and we asked people if they studied or they did not study. And then we also asked them if they passed or if they failed. So obviously some people who studied, most people, hopefully, who studied passed, but there could have been some people who studied and didn't pass. There certainly are people who don't study and pass, and then there are people who don't study and don't pass. So what we want to do is we don't just want to say, did you pass or did you fail, because that doesn't really help us out. Did you pass and study? Did you pass and not study? Did you not study and fail the test? Did you not study and pass the test? Those are more specific questions that will give you more information about your group of people. Each entry in the two-way table is called a joint frequency. So these four numbers are called joint frequencies. 21, 1, 2, and 6 are joint frequencies. So now we just answer questions based on the table. How many of the students in the survey above studied and passed? So you find the intersection of studied and passed, and you see that there are 21 students who fit into that category. There's another thing, and it's called marginal frequencies. And that's when you add the rows and columns to get a total. So if I asked you how many people passed the test, you wouldn't say, well, 21 studied and 2 didn't. You'd say 23 people passed the test. How many people failed the test? 7 people. So then you add those up and you would get 30. And I could also ask you how many people studied, and you'd say 22. How many people did not study? You'd say 8. And the way that you can check yourself is if the sum this way equals the sum this way. Sometimes when you're doing a two-way table, you'll maybe miss a number or something, and you won't get the 30 going in both directions, and then you say, wait a second, something went wrong. So these red numbers are called marginal frequencies. They're the sum of the rows and the columns. All right, so we have to make a two-way table here, and the things that we're asking are, do you ride the bus or not ride the bus? And how old are you? So let's do age and bus. And what I want to know is, do you ride or not ride? I also want to know your age. So 12 to 13, 14 to 15, and 16 to 17. I also want to make sure that I don't forget to do the marginal frequencies. So I'm going to do this so I remember. And this is just how I would set it up. You obviously, and it's, everybody would set it up differently, but these are the important things that you need. All right, so how many people are 12 to 13 and ride the bus? That's 24. How many people are 14 to 15 and ride the bus? That looks like 12. How many people are 16 to 17 and ride the bus? That's 14. I'll do the marginal frequencies at the end. How many people are 12 to 13 and don't ride the bus? How many people are 14 to 15 and don't ride the bus? How many people are 16 to 17 and don't ride the bus? So now I'll do my marginal frequencies. Add up the numbers going, I'll do down first. So that's 40, 25, and 35. That's 50 going across. and 50 here as well. So I want to make sure that I get 100 going in both directions, because 50 plus 50 is 100, and yeah, I get 100 going both ways, so that works. Okay, so now let's move on to example 4. Use that two-way table to answer letter A. What percent of the students in the survey above ride the bus to school? Don't ride the bus to school, and we're going to organize it in another two-way table. So this setup is going to look the same. I've got bus, and I've got age. And it doesn't say to represent the marginal frequencies, so I'm not going to include that section. What percent of the students in the survey ride the bus? So how many people are there that are 12 to 13 years old? There are 40 people. So out of those 40, how many people ride the bus? It's 24. So 24 out of 40 is what as a percent? It's 60%. So blue is really what they're looking for. The red is really my math work to get the answer. So out of those 40 people, then there are 16 people that don't ride the bus. So that's 40%. How many people are 14 to 15? 25. How many people ride the bus? 12, which is 48%. Out of those 25 people, how many don't ride the bus? That's 13, which is 52%. And you should see that they add up to 100, which makes sense because we're representing all the people in that category. And then the last one, there are 35 people here, 16 to 17. 14 of them ride the bus, which is 40%. And out of those 35 people, that means that 21 do not, which is 60%. Now, if you were to do the marginal frequencies, they would actually not be accurate. So since it doesn't mention marginal frequencies, don't do the marginal frequencies. Additionally, their sums are not going to be the same because you're representing the percents. So letter B, does the table that we just did show a relationship between age and whether or not someone rides the bus? So obviously, if you look, the older kids are, the less likely they are to ride the bus. The older they are here, the more likely they are to not ride the bus. So these really say the same thing. So I'll just say in one sentence, yes, the older a student is, the less likely they are to ride the bus. If you have questions, write them down and ask me when you come to class.